Schweber from Surveyor Health, and today we're going to be talking about the conscious surfer, surfing the quantum edge of many worlds. Basically, the idea is that for a long, long time, people have been looking for a place, for some elbow room or some white space that consciousness and free will could occupy. And I've been recently rereading the founders, Bohr, Heisenberg, von Neumann, etc., in light of today's knowledge, and have seen a couple new insights, I think. I think there's a new degree of freedom, and it's not where we've been looking. It's in a different place. So we'll see that. So the agenda for the talk, a few comments before we begin, just to set the orientation. We're going to look at some different models of the world, and then figure out, well, where is the freedom? We'll then actually compare the models. We'll look at this model that I'm presenting, and then there are some open questions and future directions to consider. So before we begin, because we've got a hard problem here, there are three things I want to say. I'm not proposing a theory or a model. I'm looking at a new framing of things we already have encountered and know. Why? Because as a mathematician, I know that a clever framing, a more suitable one, can make a very difficult problem straightforward, a straightforward problem easy, and so finding a frame that fits better is useful. Also, from software development and architecture, there's a concept of separation of concerns. And what this means is you want to be able to factor something apart. Imagine factoring an algebraic equation. But in software, you typically want to keep the function of the system the same while changing its architecture so that it's more understandable, manageable, monitorable, extendable, etc. And lastly, for this entire presentation, except maybe one side comment, I'm taking an epistemic stance. I am not making any ontologic commitments. So don't necessarily think I'm an ontologic dualist or worse. So here's my proposal in a nutshell. Linda, who's been working with me for 35 years, said, I needed, since I've got so much quantum mechanics in here, I need something simple. And so consciousness is not a passive observer like we often think it is, but it has a degree of freedom by which it can favor actualizing selected potentialities at the edge between classical and quantum behavior. And so in text speak, it's that consciousness can favor the observation of selected eigenvalues related to the superposed eigenvectors. And what's interesting, as we'll see when we get into the depth of the talk, that this may underlie both customary brain function as well as anomalous interactions across space and time, in other words, psi phenomenon. So I'm going to start with models of the world, and I'm going to go into each of these individually. But to begin with, what I want to portray is that these sort of overall conclusions, that classical is very determinate and it's at odds with experimental evidence. Enough said. It also doesn't show much room for will or for consciousness, except if you like zombie consciousness or the variety of free will that Dan Dennett wants, but I don't. Next, there's quantum models, and they're clearly open. There's openness. They're not causally closed, especially if you look at orthodox in Copenhagen, but they suffer some problematic gaps, other hard problems. Besides the hard problem, there's also the measurement problem, which Michael suggests may be solved. We'll see. And then lastly, there are determinate varieties of quantum models, which are like many worlds theory, etc. So let's look at these in a little bit more depth. So imagine for a moment we've got a line land, a one-dimensional space. And so we have this zero-dimensional particle moving along a one-dimensional path. And we've got a crucible space-time diagram, which basically says, well, for a while it just hangs out in one place, and then it goes to the right, and then it goes to the left, and then it goes to the right. And of course, these wouldn't be straight lines, they'd actually be parabolas or such. But the idea is it's all determined. This is what Einstein wanted. Okay? Even with relativity, which is why we've got Einie up there, we want to be able to say it's all laid out, it's determined, and we're going to forget about these trivial questions about consciousness and the experience of time or the flow of time. That's sort of not scientific. Well, I think we can pretty much, as the industry has, discard that and move on. So next we've got quantum, and I'm representing this in the Copenhagen or orthodox interpretation. And essentially, instead of having determinate paths, you have quantum jumps. And I'll go into this motif I have, which has to do with your typical preparation, operations of preparation, which induces superposition, and then a measurement interaction or detection, which then is, in orthodox Copenhagen interpretation, causes the collapse of the wave function, a reduction of the wave packet, or the state vector. Now, what's interesting here, the reason I put Morpheus in there, is because when Einstein came up with relativity, he realized that he was shifting our innovations in theory down to the geometry of our model of the world to come up with relativity. But when Bohr and Heisenberg came up with quantum mechanics, they were actually innovating at a deeper level, below geometry at the level of logic. And my own mentor, David Finkelstein, actually took it down below quantum topology, even a more simple state. But anyway, that's where the commutative property of operators no longer applies, or the distributive property in the logic is removed, and therefore becomes more general. But we have this problem, the quantum measurement problem. Why does the state vector collapse? So that's the problem there. And oops. Now, I do want to focus on this one process that I'm calling the quantum edge. I'm going to tip my hat to Chris Langton, who had come up with the edge of chaos, at the balance between complexity, order, and disorder. And I think we have something similar happening here, which is where you have, in this motif, you've got a preparation action, it induces a superposition. I'm symbolically identifying or representing three different eigenvectors, eigenstates here. And eventually there is an observation in orthodox quantum theory that instantaneously, as acausally, reduces to a collapse of one of the eigenvalues associated with one of the eigenvectors. And the thing is, I see in here three potential degrees of freedom. One is, what is the trigger of the collapse? Okay. Second, what is the timing of the collapse? How long does it take? Is there a threshold? And lastly, what is the observed eigenvalue? How is that related? So these are three things we're going to look at. If we look at OR layered on top of traditional Copenhagen interpretation, what I've done is I've taken one of Stu's and Roger's diagrams here, I've put my own motif on, and then I've noted that in terms of these three degrees of freedom, first, the collapse event is objectively triggered, both in timing and in the event. And so those are no longer degrees of freedom for the potential observer. The remaining degree of freedom, even though it's called orchestrated reduction, objective orchestrated reduction, it still has one degree of freedom that is non-objective, and that is the actual selection of that eigenvalue, what comes out. So when you hear objective reduction, it's partially objective, it's hybrid. And then we've got many worlds interpretation with you, Everett III up there. And here the idea is, let's not have collapse. I'm sure most of you have heard this all before. Let's not have collapse. Let's assume, by looking at the Schrodinger equation, that it is evolving in what's called process 2 by von Neumann. It's evolving deterministically in time. Not so different than having an equation that represents a parabola of an artillery shell, and you want to know, how does its position after it's fired? What is its position, and how does that evolve over time? In this case, though, instead of one trajectory, you have multiple trajectories simultaneously in parallel. And so that's why each of these worlds and world lines is all realized. Well, there's a problem with this. So first, the quantum measurement problem is now resurfacing. Why? Not because someone's interacting with the system to cause a collapse and realizing an eigenvalue, but because we have the hard problem, and how do you get the experience of time, right? Why am I conscious of only one world? Well, someone came on top of that and said there's the many minds idea. Every world has its own mind. Well, why isn't there any relationship between those minds? We don't know. Why am I conscious of this world and not another? And the answer that I've heard is sort of like the strong anthropic principle, which is rather circular, and it's not satisfying to me anyway. And then, well, is there even a choice? And that starts asking us, it begs the question, is there something beyond causality? Is there a selective process beyond causality? and I would suppose there is. And I think there's a very key thing here, a quote by David Deutsch from his book Fabric of Reality. There is no fundamental demarcation between snapshots of other times and snapshots of other universes across the many worlds theory, a multiverse. This is the distinctive core of the quantum concept of time. Other times are just special cases of other universes. You can think about that for a few minutes. So now let's compare the models. So what we're going to do is we've got the model, we've got what its causal structure is, open, closed, etc. What is it in relation to collapse, triggers, timing of the collapse, the eigenvalue that's observed, and then what are these models compatible with? So to begin with, I'm going to look at the classical determinant and classical, or rather quantum determinant. And you notice they're almost identical. The only difference is for classical, there is no collapse, it doesn't even apply. Okay? There's not a thought because there's nothing to collapse from. Whereas here, it's just no, there's not a collapse because all eigenvalues are realized. And then when you look, though, and with regard to the other attributes, it just doesn't help us here with our hard problems. Now, if we look at quantum mechanics, Copenhagen versus Orko, and I better pick up my speed here, what we also see is that quantum mechanics is open because there's von Neumann process 1, but when you apply Orko-R, it's closed in two ways, but still open to the determination of that eigenvalue. So it's sort of partly open, partly closed. And von Neumann said that the actual selection by the observer of the observed eigenvalue happens acausally. That's his specific words in 1932's Mathematical Foundations of Quantum Mechanics. Whereas here, and now I need to correct this, I'm not sure what to, instead of quantum gravity, it's gravity applied to a quantum collapse, which takes too many words for a PowerPoint. But otherwise, it's rather interesting. We've got determinate timing, we've got indetermination in the values, and all of these things we care about, there's a potential compatibility. So let's see what we can do with this. So we've been talking about Lebesgue. Fortunately, we've had speakers that have freed us of some of the chains and terrible binds of Lebesgue. But to the extent that there is any validity in Lebesgue, where is the freedom? So I really wanted to cite the spoon boy. And of course, there the spoon boy said, you can't bend the spoon, that's impossible, there is no spoon. Instead here, I want to say that in the world plane, think of it as many worlds or whatever, it is causally closed. There is no room there. And we keep trying to squeeze something there, but maybe we should take a few minutes to talk about where there may be freedom. And so I want to talk about the von Neumann-Heisenberg cut. So what they basically said, and there's von Neumann, who I've called Wigner's best friend forever. Anyway, we've got an apparatus, we've got a quantum source, a laser producing a photon, we've got an interferometer, we've got detectors, we've got our human observer. I'm not going to read him, I'm going to go through the animation. So one place we can put the cut is von Neumann says we can partition the system into the photon itself, the quantum understudy, and everything else. But this barrier, the cut is movable. We can put it where we want to. It does not make a difference to the values we measure in the laboratory. We can instead put it in the middle of the apparatus in terms of the interferometer, just before the detector. We can even push it closer, and now we can just have the photon, its source, and the interferometer as one part, one partition, and we can have the human as the other. But von Neumann did not stop there. He said, we can push the cut as far as we want into that human being, into the retina, into the brain. But he didn't stop there. He then said, we can push it all the way till the partition on the left is physical and the partition on the right is non-physical. And he specifically labeled it as an abstract ego. I thought, where does that come from? So if you actually look into the philosophers of the time, like Hegel used this term, abstract ego, who said, if you could take the ego and purge of it all content, which would not be a logical operation, maybe it's a quantum logical one, that's a different topic for a different talk, but maybe you would reduce this to pure being. Well, that definitely caught my attention. So, and I should mention, there are other ways of doing this partition. David Finkelstein used to partition the system understudy on the far left of the slide, And then the other partition, which you call the exosystem, is everything else, all experimenters. Not the universe, but the universal quantum. So there are other ways of partition. But what's interesting is there's something I'm calling the Radon cut. And this is a series of experiments that Dean's been doing at IONS. I think there might be some replications, but I'm not sure. And if you look at the left side of the slide, you have a traditional two-slit diffraction experiment. And the key thing here is, if you have no detectors by the slits, and you've configured that properly in order to support interference, you get a wave pattern, even if you do like Thomas Young did, put one photon through the system at a time. You get wave behavior. But if you decide to insert a detector in either of these points, which could potentially observe that photon going through that slit, which means you now get particle, you're detecting particle behavior, well, the interference fringes disappear. And the more precisely you locate that electron, the more sparser your fringes become. So clearly, by interacting with the system, this is Heisenberg's indeterminacy relations at work, by interacting with the system, you are limited in the knowledge you can gain. And here's where it gets really freaky and interesting. Okay, in Dean Rain's experiment, he takes a meditator and he firewalls them off, takes them, puts them remotely, shields them electromagnetically, and tells them, I want you to attend on that two-slit diffraction and see if you can identify which slit it's going through. And this is freaky. So, typically Dean is doing experiments that show the powers of psi, right? We think, oh, it can look over space and time, retrocausal, precognitive. Well, guess what? When the meditators attend on this, they are subject to quantum mechanics and the indeterminacy relations, same limitations. Okay? It's the same effect. They meditate on the slit, and guess what? The diffraction pattern is quashed. And the more carefully they observe, the more it's quashed. So, to me, I have to just put in bold, it's freaky that our access to knowledge via psi is just as limited by quantum mechanics as our access to knowledge through a measurement chain. And so, the one point I'll talk about realistic viewpoints, if you insist on coming up with a quantum ontology on what's really happening, I think we need to shift away from physical devices and measuring chains and think about knowledge, phenomenal knowledge, and our access to it, and the limitations on that. So this starts to look very much like the margins of reality from Robert John and Brenda Duna, the former Pear Lab, and there's the margin in this plot of thousands of trials of where users either can predict or affect, I will call it physical information. So, where am I coming to? I'm basically going to say, we've got this idea, the abstract ego, the observer, who is now floating above, surfing the world plane, the quantum edge of the world plane, between classical and quantum behavior. And so I'm going to say the surfer's conscious free will, as von Neumann would say, causally favors, to Michael's prior talk, favors paths at branch points within this margin of reality from across the many worlds. So, and I have Gene Wilder down there saying, it's all exciting. Okay, I've had, my scientific worldviews have been very open, but I've never found a place for them compatible with concepts of spirit and soul. And now it's like my world has opened up, and now I can see, well, maybe that can make some sense. So now we add that to the model. We have it down at the bottom, this conscious surfer. So we've got this new degree of freedom. And whether it collapses or not is optional. We can apply it to many worlds. We can apply it to OR. We can choose that. It can be acausal or gravity affecting a quantum collapse. We have determinate timing, but indeterminate value. And so I've got some open issues and ideas. In terms of the world, could there be any residual properties that this abstract ego, which I'll now just call the surfer, may have, since everything emotional and physical and mental is down in the world plane? Is there any room for additional residual properties? Are there any other degrees of freedom besides this preference for a certain observed eigenvalue? Does a surfer have some kind of access across the world plane, which might be compatible with various psi models? And is there an idea that many worlds might actually be on demand? Not the full evolution, but with every measurement, you're being forced, perhaps by OR, by quantum gravity, into making a choice, but you then make the preference for what value you're going to observe. I'm also wondering if some materialistic systems are more favorable to surfing. So for example, microtubules and braids versus rocks and snail shells. Altered states of consciousness, however they are induced, prayer, drugs, etc. Behavioral configurations, so a long-time meditator. And then there's questions about the surfer. Is there one, or is it composite? One or multiple servers per what we consider an individual person. If multiple, what's their relation? Can surfers experience each other through the world plane? This one that's very near and dear to my heart and mind, can quantum logical operators lift that ego to an abstract ego? But that's a separate talk. And then on free will, what does it mean to acausally make a selection? Or, and I almost hate this, besides veto power, is it more like Pandora and Facebook? Is it liking and disliking or whatever? And if it is, boy, I see those fitting into angle brackets very easily. But I think Dirac might roll over in his grave. Yeah. And then lastly, if the surfer is performing selective acts and there is a capability for memory, do we have the ability to have evolutionary dynamics? And I think you brought that up too, Michael. So the last thing I'm just going to say for future directions, and then I'll stop. Without briefing this, I think there's a lot of things that have been in the pseudoscientific, religious, philosophical territory that within this framing, we can now even think about. And I'm very excited to start doing that. Some of these are extremely interesting. Incarnations in parallel, before birth, after birth. Are these surfers essentially the pan-proto-psyches that we've been talking about at these conferences for many years? A lot of interesting things here to talk about. And that's where I will conclude, so hang tight. I will take questions. Questions? Yes?
I think Radin's experiments were really, really interesting. Dean Radin's experiments. Do you know if anyone's ever validated those yet?
I do not know yet. I've been trying to get some time with Julia Mossbridge to talk about this, and our schedules still haven't aligned. Yeah. Other questions? Yes?
I'm actually a good friend of Daryl Bem. How do you, I mean, his stuff has not been replicated, supposedly. How would you view what he was finding in terms of the suggestion of psi abilities?
So let me just ask you, when you focus on him, are you thinking of something specific to his work, different than Paralab, Radin?
Radin is what I'm thinking.
Oh, you are thinking of Radin,
yeah.
Specifically?
Yeah.
Yes. Not Bem. Radin.
No, I was thinking of Bem, but I don't know if you're aware of his methodology, but he would flash pictures to students and
The presentiment effect.
Right, exactly, presentiment.
Yes.
Which has not been replicated.
Well, there have been replications. There's been Dick Bierman's multiple replications, actually even before Bem's work.
Really?
Out in Europe, yes.
I didn't know that.
Yeah.
Oh,
Yes.
interesting.
You just can't trust what you read on Wikipedia.
True.
It must be written in DC or
Really?
something. I don't
But
know.
damn, I write some of that stuff.
Well, good. We might need to have our own counterintelligence in there.
Actually, can I jump in there? Actually, I was on the Bem stuff.
Yes.
That was actually designed to be, his work was designed to be replicated, and I was following that pretty closely for a while, and they do have a follow-up paper in draft, and where they're collecting the multiple studies for so long story short, lots of replications. How it's actually panning out, I forget. So yeah.
Well, we definitely need
Watch
to.
this space.
Okay, we need to petition Stu to have more speakers in that realm at the next conference.
I think so, yeah.
Yeah. Any other questions? Out of time. Thank you. Oh, yes, Daniel.
No, it's
Oh,
okay.
okay. Oh, Daniel, I'll just mention you. So the reason I asked you that question is it seemed to me that if we apply conscious surfers to OR, then now we're having gravity forcing a choice. Okay, it's forcing a collapse in a determinate amount of time,
Yeah.
but it's not telling us what option we choose. So it seems like the agency may be removed, but our free will is still there.
Yeah, but it might be not your free will, but it might be the free will of quantum gravity acting, acting through quantum computation of brain. It is not your free. It is not your. I don't know how to explain it. It could not be your agency, as you said, but the agency of quantum gravity. That's it.
Yeah, right. But it's still us choosing which place to land, or at least preferring.
Yes, but you still having the agency of quantum gravity.
Yes. Yes.
Yeah.
So you don't have. We wouldn't have in that model full volitrium. Is that how you pronounce it?
Yeah, William.
Yeah. We wouldn't have full volitrium. We'd have partial volitrium.
Yeah. So I have to add the quantum gravity to William.
There we go. Thank you so much.
Thank you.
Thank you. Very good.